Welcome to the student the brand. So now you can see. So this is our Shiva sir. Today topic is light refraction. So now we'll explain about light refraction. I'll discuss, right? Okay. So here you can see. Okay, done. So in the previous class, I explained about completely reflection. So now we are completely discussing about refraction. So today class completely about refraction. We'll see now. Okay, so be ready. Refraction. Okay, so now we'll see. So how the refraction will be. So what is the refraction? Definition, everything. So now this will be updated. So final price is 500 rupees. Okay. So that is fixed. You can see now. So notes. So about notes. And so CBSE Grade-10 Physics. So cost 500 rupees. 500 rupees. Okay. So those who are interested, you can contact to this number. You can contact to this number. So those who are want to join, okay. So you can join to the class. So will be doubt will be clarified. And so as I said, JEE NEET foundation classes are going to start soon. So within okay. So within week, I'll let you know. JEE and NEET, those are interested to join to the foundation classes and complete the course. And the topics also I'll be explaining. I'll let you know the details, everything, schedule. So you can follow the community post. You can check once. So those are there. So keep on check once. Automatically you'll get to know. You'll get the updates. So when it is the class, so how it will be there. Everything you'll get the notifications. So subscribe my channel. So you'll get the all the notifications, everything. And one more thing, those who have any doubts related to any topic also, you can ask me. So I'll clarify. I'll explain the topic. So today completely about refraction. So refraction phenomena I'll explain. We'll see. So refraction, how the refraction will be there. So what are the points we are going to discuss in the class. So everything I'll explain. Refraction. So here, observe. So myself, introduction again in the class, today class. So CBSE Grade-10 Physics. So by Shiva sir. So BTech Mechanical completed. By passion, it's my passion no, to teach. So it's it's only one thing driving me. So in this 10 years. So initially I was thought like that, how many Why, how the people can teach, how the people will be in the same profession like this many years. So initially I thought like that. Later once I joined, in teaching field, so later I realized, so it's only the passion will drive you, nothing will drive you, no external motivation, no. So everyone will ask you, everyone will tell you, so what is this, like that. But no the one only one thing will drive you is your passion. Okay, your passion only will drive you. Okay, so in towards your dreams, towards your goals. One thing, remember, whatever you do, so do with the passion. Whether you are studying, so keep a goal, work for it. Whether you succeed or not, that is a later part. Success or failure, that is a bonus, you keep it as a bonus. Your work is first. Work first, no problem, nothing happens. Start working, okay, on your goal, on your dreams. Try to work on it. So one day, some other day, definitely you will see your results. Definitely you get your results. Definitely you reach your goals. Definitely you reach your dreams that day. So what are problems, what are the struggle you are facing this many years, that everything will be way off by seeing that success. Okay, so surely you'll get it. Try hard. So go into the deepest level of your work. Try to do your work. Okay, so keep your all your nerves, brain. Okay, so muscle, everything keep on one work. Try hard, so hard. So even you, no one can beat. Okay, even your inner self should say, yes, you're doing in a, you're doing, you're going in a right way. Like that, it should feel. Okay, so only see, at the end you have to answer to yourself. At the end you have to answer to yourself. Okay, so for that you have to work for that, dream for that, live for that. Definitely will get success. Okay, so now we will come to the point. We'll work out an reflection, light reflection, diffraction. Refraction topic, refraction topic, refraction topic. Okay, so what is a refraction? So I'm talking about uh, nature of work, nature of work. Okay, how you have to be, how you have to work. So actually I'm teaching physics. So by passion I'm teaching physics. So I want to say a few words to you, that's why I'm telling these words. Maybe it will be helpful. So maybe I'm thinking it may be helpful to you, so you can take it. If not, no problem, nothing will happen. Okay, so whatever it's required, you take. Among all the channels and videos are there in YouTube, so you came to this channel and asking means, so whatever you want, you're going for it, right? So if online offline classes available, no, as of now, Badri Agarwal. So as of now, I'm taking online classes. As of now, I'm taking online classes. So I'm in Hyderabad. I'm in Hyderabad. As of now, I'm taking online classes. Those who are interested, you can contact to that number. Contact to this number. So further details will be. So you'll get to know. Understood? So, but one thing you keep in mind. One thing you keep in mind. Whatever you do, believe in our work. Okay. So whatever you're doing, whatever you're doing, so believe in your work. So do hard work. Do always hard work. Definitely you'll do it. definitely will work it. Okay, so definitely it will be worthy, right? So come to the point. So refraction is nothing but, so I'm considering this one. So this is the rarer medium and this is the denser medium. Rarer medium, denser medium. Light is moving from rarer to denser, rarer to denser. Okay, so this is a normal line, normal line. Okay, so come to the point. So I'm considering this one. So this is the incident ray. So I'm considering this a refracted ray, refracted ray, incident ray and a refracted ray. So incident ray, refracted ray. So when the light is moving from one medium to another medium, so I'm considering this a rarer medium and this one is a denser medium, rarer medium and denser medium. Okay, when the light is moving from rarer to denser, it bends towards the normal line. It bends towards the normal line. So the bending of the simple definition, easy definition, so you can learn, you can remember in easy way. So that definition I will tell. So the definition is, when the light is moving from one medium to another medium, it bends towards the normal line. It bends towards the normal line. Okay, the bending of the light ray at the interference of the two media, the bending of the light ray at the interference of the two media is called refraction. It's called refraction. So here you need to understand one thing. When it is moving from rarer to denser, it bends towards the normal line. When it is moving from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, if it is moving from denser to rarer, see here like this. So I'm taking the normal line like this. So I'm considering here. So this incident ray and this is the refracted ray. So I'm considering this a normal line and this is the normal line. So incident ray and a refracted ray. Incident ray, refracted ray. So here you can observe one thing. Light ray is moving from rarer to denser. Rarer to denser. Rarer medium means speed of light is more in the medium, that is called rarer medium. Speed of light is less in the medium, that is called denser medium. Speed of light is more in the medium, rarer. Speed of light is less in the medium, denser medium. Speed of light is more in the medium, whereas speed of light is less in the medium, denser medium. So when it is moving from rarer to denser, it bends towards the normal line. It's bending towards the normal line. Okay, so bending of light at the interference of the two media. See, if it is moving from rarer to denser at the interference, at this point it is bending, okay, towards the normal line. So if you consider this the this is the rarer, same thing. This is the rarer medium and denser medium, same thing only. So there is no other change. So mediums does not change. I'm keeping the medium constant. So I'm keeping the medium constant. So here rarer medium, denser medium, and it is moving from rarer to denser. At the interference of the two media, it bends. So here also I'm taking, if the light ray is moving from denser to rarer, it moves away from the normal line. It moves away from the normal line. Clear? Understood? So do you have any doubt? Simple definition is, so when it is the light ray is moving from one medium to another medium, the direction of the light changes at the interference of the two media. The direction of the light changes at the interference of the two media is called refraction, or simple we can say. So simple definition is, the path of the light ray changes when it is moving from one medium to another medium, one medium to another medium. So that is called refraction of light, refraction of light. Okay, so even if it is moving from rarer to denser, it bend towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. So because here speed is decreasing, so here in this case speed is decreasing, but here speed is increasing. So speed is decreasing, that's why it's moving towards the normal line. Here speed is increasing, that's why it's moving away from the normal line. Clear? Do you have any doubts? Anyone have any doubt? So just let me know. If you have any doubts, you can just check once. So we'll see. And one more point is here, angle of incident is greater. So this is angle of incidence and angle of refraction. Angle of incident and angle of refraction. Angle of incident is greater than angle of refraction. So here also, here this is the angle of incidence and here angle of refraction. Okay, so rarer medium, denser to rarer medium. So when it is moving from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. So the reason behind it is moving. So this is the normal. So I said this is the dotted line. Actually, this is not, this normal line is not existed. Okay, so we are imagining. Okay, this is the normal line. Normal. Okay, so why we are asking it is a normal? Because we are drawing perpendicular line, perpendicular to the surface. This is the surface, interface I can say. So interference between one medium to another medium. So at this point it is interference. So this is the normal line. This is not, this dotted line is considered as a normal line. Why it is normal? Because it makes 90 degrees with the surface. So with the medium. So you can see here 90 degrees making. Okay, so that's why it is normal. It's a perpendicular surface, perpendicular to the surface, perpendicular to the surface. So it makes 90 degrees. That's why we are considering as a normal. See, this normal line is not existed. Okay, so it's not there. For our understanding, for our no, better understanding the phenomena of refraction of light, like a incident ray, refracted ray, where it will bend exactly the point of incidence. So there you are drawing. So there the angle we can say. So here also angle we can take. So according to the angles, we can consider how much degree it is rotating, how much it is bending. So based on that one we can say, right? So here also it is moving from denser to rarer. It moves away from the normal line. Away from the, here is the normal line. It's moving away from the normal line. Clear? Any doubts? If you have any doubts, you can let me know. Otherwise, I will go to the next topic. So conditions are there. So conditions for no refraction. When refraction does not takes place. So when it is means, see here, this medium. Suppose here rarer medium. So rarer medium, denser medium are two different mediums. So here rarer medium considering air. Here denser medium considering water. So water I'm considering. This is the water. Here also, best example, see, not only water. Sir, why only you are taking water? Why can't you take a glass or some other material? Yes, we can take, no problem. So instead of water, we can take glass also. Different medium we can take. So one is air. So I'm considering one is air. Another one we can take water. Another one you can take water, means another medium I'm considering. Okay, if it is moving from one medium to another medium, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. Away from the normal line. Clear? Yes. So this is about refraction of light. So conditions for refraction of light. So if suppose you can see the light. Okay, so it's falling on me, right? So you can see the light. So in this, from here to here, okay, from here to here you can see the light ray is same. Here to here light ray is same. So in the same direction. So mediums are different. If you are taking this there, this is also air. Or this the refractive index, this refractive index will be same. If two mediums refractive index is same, then there is no refraction. And one more point is, if light ray passes along the normal line, if the light ray passes so along the normal line, so no refraction takes place. No refraction takes place. It moves like that only. So what is a refraction? Refraction is nothing but changing the light direction. Changing the direction of light ray when it is moving from one medium to another medium, right? So here it's not changing. So then no refraction, right? Yes and no refraction. Yes, that's enough. So that is about refraction of light. So and in the exam hall they will ask about refraction. In the previous board exam they asked one question. In the previous board exam, they asked one question. That question is, draw the glass slab in CBSE. In CBSE exam, so they asked about one question. Draw the glass slab. How refraction takes place when light ray is passing through the glass slab. and with the help of diagram explain. That's enough. Very simple question, 3 marks question they given. So see, we can't neglect any question because each and every question is very important here, right? Yes. So we'll see now. We'll go with the one more. So refraction of light. Next, loss of refraction. So we'll talk about loss of refraction. Okay, loss of refraction. Loss of refraction. So what are the loss? Loss, if you consider, okay. So first point, as I said, so you can see the diagram. This is a diagram, right? This is a diagram. Incident. So I'm considering like this. So this is a refracted ray. Okay. So first point is incident ray, refracted ray, normal line lies on the same plane. Incident ray, refracted ray, normal line lies on the same plane. Incident ray, refracted ray, normal line lies on the same plane. Once again, incident ray, refracted ray, normal line lies on the same plane. Incident ray, refracted ray, normal line lies on the same plane. Second point is, incident ray, refracted ray, normal line lies on the same plane. Here, this is the incident ray, refracted ray, this one is the normal, this one is the normal. And one more point is, so the ratio of sine of angle of incident to sine of angle of incident to sine of angle of refraction equal to constant. Refraction equal to constant. The ratio of, here you can observe, the ratio of sine of angle of incident to sine of angle of refraction equal to constant. The ratio of sine of angle of incident to sine of angle of refraction equal to constant. The ratio of sine of angle of incident to sine of angle of refraction equal to constant. So that is a loss of refraction. So these two are loss of refraction. Once again, incident ray, refracted ray, normal line lies on the same plane. Incident ray, refracted ray, normal line lies on the same plane. Incident ray, refracted ray, normal line lies on the same plane. Incident ray, refracted ray, normal line lies on the same plane. So the ratio of sine of angle of incident to sine of angle of refraction equal to constant. That is equal to n. That is equal to n. Is it clear? Do you have any doubts? If you have any doubts, you can let me know. So related to loss of refraction, related to refraction phenomena. Any doubts? If you have any doubts, you can let me know. Yes. Okay. Fine. So next, we'll go to the next one. Glass slab, I'll explain. Glass slab. Refraction through glass slab. Refraction through glass slab, I'll explain. So refraction through glass slab. So what is the refraction through glass slab? I am taking this a glass slab. So I am considering this a glass slab here like this. So I am considering incident ray. This is incident ray. So this question they ask for 3 marks. Just to drawing the diagram. That's enough. They ask for 3 marks. Okay, so and this is the refracted ray, and this is emergent ray, incident ray, refracted ray, and emergent ray. So if you extend this incident ray, so if you are extending this incident ray, okay, so suppose if you extend like that, so it will become parallel to the emergent ray. So this is the emergent ray, this is the emergent ray, incident ray, refracted ray, emergent ray, incident ray, refracted ray, emergent ray, incident ray, refracted ray, emergent ray. This is the normal line. Okay, so this is the extending of incident ray, extending of incident ray. So this is the angle between incident ray and normal line. This is also angle between incident ray and refracted ray, and this is the angle of emergence, angle of emergence. Okay, so now you can see I am considering the distance between here, the distance between emergent ray and extended incident ray. The distance between emergent ray and extended incident ray is called lateral displacement. Lateral displacement. Lateral displacement, or simply we can say lateral shift. Lateral shift, or simply we can say lateral displacement. Lateral displacement. Is it clear? Anyone have doubt related to this? At least if you respond, then I can understand whether you are understanding. I will go as it is. Okay. So if you have any doubts, you can comment. You can respond. So we'll work out on it. Hey, hi Ish. Hello. Hi Aish. Okay. So incident ray, refracted ray and emergent ray. Incident ray, refracted ray, emergent ray. So this is about glass slab. When light ray is passing, so here it is I am taking air, and here it is the glass slab, glass, and again it is area, air, glass, air. Okay, so when light ray is passing from air to glass, it bent towards the normal line. So again it is passing from glass to air, it moves away from the normal line. It moves away from the normal line. Clear? Any doubts? Right. So here one more point is, if it is moving from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. Away from the normal line. So and one more point is lateral shift. Lateral shift is the distance between emergent ray and your extended incident ray. Oh, thank you so much. So the distance between emergent ray and extended incident ray, is called a lateral shift. Lateral shift. Okay, lateral shift I am taking, lateral shift. And one more point is there, vertical shift. Vertical shift. So I am rubbing this one. So just check once. Vertical shift. Vertical shift. Vertical shift. So what is a vertical shift? Vertical shift is nothing but, so if you are taking the coin, if you are taking the beaker like this is the beaker I am considering. So if you place the coin at the bottom, so you are standing in somewhere here, so at one position. So there, that time you can't able to see the coin. Okay, you can't able to see the coin. So when you pour the water, so immediately the coin position rises up. The coin position. Actually, the coin is at the bottom of the beaker itself. Okay, so the coin is at the bottom of the beaker itself. The coin is at bottom of the beaker itself. So the position of the coin appears here. The position of the coin appears here. So the distance between actual position to apparent position. The distance between actual position to apparent position. The distance between actual position to apparent position is called vertical shift. Vertical shift. So the distance between where are you from? So guess where I am from. Any guess? Just now only I said. Okay, done. So the distance between actual position to apparent position of the coin or object, we can say. The distance between actual position to apparent position of the object is called vertical shift. The distance between emergent ray to extended incident ray, okay, or initial direction of the incident ray is called lateral shift. Lateral shift. Just check once. So very important. So you can consider refraction through glass slab. So this question is very important. So it may come for 3 marks. Definitely 3 marks this time. So I'm expecting. So 3 marks. See here, nearly 5 marks questions are there. So one is refraction definition they will ask. Refraction, what is the refraction? Second one is refraction definition they will ask. Second one is lateral shift they will ask. And the next one is vertical shift they will ask. Lateral shift and vertical shift. Lateral shift and vertical shift they will ask. And the glass slab diagram. Here this glass slab diagram. And related to this refraction, there are few more questions are there. So best example, a coin is placed in the gas tumbler. So you can see near to the shop, in front of the shop. So lemon will be placed. Okay, lemon is placed in the gas tumbler. It appears to be bigger. It appears to be bigger. That is the refraction only. And one more thing, so taking the beaker, so pour water and place the pencil. Okay, if you place the pencil at that point, it appears to be bent at the surface of the water. It appears to be bent. So that also they will ask. Okay, so one is uh, lemon placed in the gas tumbler. Second one is coin placed also when you place the coin. So because of the refraction, so if you pour water, it appears to be it appears refraction. And the next one is about a pencil. So pencil placed in the water. Okay, it appears to be bent at the interference of the water. So these are the points. So these 3 questions are very important along this question. So these 3 questions are very, very important. So one person asked a question. Question is, sir, where are you from? So I didn't answer to that question. I said, guess the answer. So he said, you are from YouTube, sir. Thank you. Thank you, Ayush. Okay, so come to the point. So that is about refraction. Okay. I will explain about refractive index. So thank you so much for giving the boost. So please, I'm asking remaining students also. So try to like, share, and subscribe, and you can share this video to all remaining students. They will also get to know. They will also get to know. So live class is going on. Okay. So they will join to the class. Clear? So I hope it is clear. Next one I will explain about refractive index. So what is the refractive index? So we'll see. Actually, one of my student name is also Aish only. Okay. So I thought my student, and I said he knows right where I am, from where I am teaching. That's why I said guess. So nice. So come to the point. Next one. Refract index. Refract. Oh, really? Yes. So refractive index. So coming to refractive index, you can see refractive index. Refractive index. Refractive index. Refractive index. Okay. So what is the refractive index? Refractive index, here there are 2 points are there in refractive index. So one is, so those are attending, at least like, share and subscribe, or at least ask doubt. Sir, what is the refractive index? Third, what is the reflection? That is, if you have any doubts, you can post in the comment. I'll check once. Okay, so now I'm considering refractive index. So there are one is absolute refractive index, absolute refractive index, refractive index. So second one is relative refractive index, relative refractive index, relative refractive index, relative refractive index. Absolute refractive index is there, relative refractive index is there, absolute refractive index and relative refractive index. So what is the first one? Absolute refractive index. Absolute refractive index is nothing but n equal to c by v. N equal to c by v. So ratio of speed of light in vacuum by speed of light in medium. So that is nothing but absolute refractive index. So n equal to c by v. Absolute refractive index is nothing but ratio of, nice, very good then. So you are 2 chapters ahead. So very good. Good job. So then it is a revision, like revision for you, right? Yes. So n equal to c by v. N equal to c by v. So your refractive index, speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium, that is called absolute refractive index. Absolute refractive index. Relative refractive index is nothing but n equal to, so you can see like this, n2 n1 by n2, that is nothing but v2 by v1. Okay, refractive index of medium 1 with respect to medium 2. So then we can say, so n1 by n2, that is nothing but v2 by v1. Okay, so here that is about, so n12 equal to n1 by n2, that is nothing but v2 by v1. Clear? Any doubts? Do you have any doubts? Absolute refractive index and relative refractive index. So one question I'll give, so related to our refractive index. So actually there is one question I'll give now. Just try to solve it. Okay. So very clear question. So n1 2 into n2 1. So what is the answer to this question? Anyone? Okay, so can you tell me? So what is the answer? So can anyone tell the answer to this question? Anyone? So I'm giving 5 minutes time. 5 minutes time. 5 minutes more. It's too heavy, right? I'll give 1 minute or 2 minutes. Shall I go for 2 minutes? So I'm going for 2 minutes. Just try it and solve the answer. Anybody? No one. So you know the answer, but no one is answering. That is a problem. So what they will feel? If I answer any means any wrong answer, or what they will think, what they will do. It's not a class, right? Okay, so your classmate may think like that. So no one will come and directly ask. So it's keep on. Even me, I will see the answer, right? Just check once, no? Answer to the question. Anyone? Or comment below. Just check once. Try to answer randomly. So again, the question is, see this one. This is the question. So I explained just now refractive index. Just now I explained refractive index. So related to refractive index. So I given this question. So 2 minutes I am giving. Yeah, actually super option where you can donate. You can donate some amount to the creator, content creator. So as of now, I didn't reach to that point. So you can go to this QR code. Those are interested, go for super chat. So you can chat in the sense super thanks, super thanks app, super thanks is there, super thanks, super chat. So they will give according to the, if you pay amount, your message will be highlighted. Okay, so like that, so many options are there. So still we didn't reach to that options. So that's why I kept the QR code. You can uh, actually I can understand, but I couldn't able to communicate. Thank you so much. So I can agree, I can accept. Okay, everything accepted here, right? Then, so here I'm saying, so 2 minutes here, 2 minutes time I given. So I want full screen karo. Uh, so due to some circumstantial problem, so I'm not able to do the full board. I'll try if it is possible. Soon I'll try. So due to some circumstantial problem, I can't able to do it. So slowly I will be doing. Okay. So meanwhile, so adjust with the thing what we have, what is there right now, and according to the surroundings, according to the situations, we are going with that. So fight for your rights, fight for your dreams, fight for your goals. Always a fight. So here actually I'm explaining the content here. I'm explaining the content here. So we need to concentrate on content itself. So more than me. So I want my content must be reached to the students. That is the reason. So okay, fine. Definitely I will do it. So I'll adjust, because if I adjust, no, the problem is some light effects, something it's happening. So I hope it is the best view for the content and for me also. That's the reason I kept. We'll see. I'll take the tip. So I'll accept the tip. I will consider the tip. I will work on it. So for better resolution and better performance of the camera and everything. Okay, and visualization, everything I'll do it. So actually answer is 1. Here I am going with the answer. So answer is 1. How we have to go for it? How to solve the answer? So here n1 by n2 into, actually here same only, right? So here is 1, here is 2. Now you do it. Here is 1, here is 2. Now you try. Actually same only I said, so that will get a square. If you do it the same, square will get nothing else. But here if you do 1, 2, reverse. So here is 1, here is 2, here is 2, here is 1. Then if you do it, you will get 1. For this one, you will get a previous one is previous one is so for this one, if you take 1, this one, previous one, you will get a square. If you take 1 and 2, so n1 square, n2 square, like that you will get whole square, you will get it, nothing else. Okay, whole square will get, but in this case, because this will get cancelled, this will get cancelled, so you will get the answer. You will get the answer, this one. Okay, fine. So any doubts still? Actually, this question, no, this question they will ask for MCQ. For 1 mark question they will ask. For 1 mark question they will ask. Very, very important question. So follow this one. Very, very important, this one. Very, very important. Very, very important question, this one. Still anyone have a doubt? Do you have any doubts? Do you have any doubts? Any doubts? No doubts? At least ask doubts. Try to ask doubts at least. I'll respond. Give me the chance to answer the questions. Okay? So one chance. Like that. So send the questions. I'll answer. Okay? One chance. Let me answer the questions. Okay? Send the questions. I'll answer it. So what are we discussing on it only? So there is one dialogue. Performance is there. You have to utilize it. Okay. So you have to take it out, that acting skills. Here also same thing. So subject. So how many questions if you ask? So that many answers will come. Then you will get the concept. Okay. So here, one more question I'll ask. Actually, so this is my handwritten notes. You can see. So there are so many questions are available. There are so many questions. So I have written this question. So everything, all you can check. All you can check. All you can check. Yeah. See. Yeah. You got it. You got it here. This is the question. This is our hero. So it's here. What is the value of 1, 2, 2, 1? So alternative, right? Reverse. You can check here. I said no, this question comes. Surely very important question. Check once, everybody. Understood or not? Yes. There is an answer, simple one. Okay. Next we'll see. Conditions for no refraction. If n1 equal to n2, here if light ray is passing like this, so this is the question. If the light ray is passing like this along the normal line, no refraction takes place. Okay, no refraction takes place. Light ray passes like that only. Then any other question? Lenses are there. That's enough. So answer is one. Actually, I said no. So if you are taking, that's enough. There are a number of questions. One question, simple question I will give. Try to answer to the question. What are the factors on which the lateral displacement of an emergent ray from a glass slab depends? The question is, what are the factors on which the lateral displacement of an emergent ray glass slab depends? That is the question. So you can check here. This is the question. Is it visible? Answer is also there only. I'm showing the answer also. What are the factors on which the lateral displacement of an emergent ray from a glass slab depends? So one is thickness of glass slab, second one is refractive index of glass slab, and third one is angle of incidence. Clear? So thickness of glass slab, refractive index of glass slab, the angle of incidence. Okay, one more question. Why does a ray of light bend when it travels from one medium to another? The question is, why does a ray of light bend when it travels from one medium to another medium? This is because the speed of light changes. Speed of light depends on the refractive index of medium. Okay, so refractive index is changing, automatically speed is changing. So speed of light depends on refractive index of medium. Okay, that's enough questions. Next, shall we go to the lens? So actually lenses are there, spherical lenses. There are two types here. All important points I have written. So very beautifully written notes. Okay, so handwritten notes, spherical lenses. Me only written this one. Okay. So I so these diagrams, everything. So now I'm considering lenses, lens image formations, everything we'll discuss. Then ray rules, image formations, actually related to lens. Questions are there. And one more point, problems also they will ask related to problems, related to lens problems. So shall I explain? Shall we go to the next one? At least give a thumb, give a like, give a comment. Sir, yes, sir, we'll go to the next topic. Then what I'll feel, okay, so someone is there to listen. So someone is there to respond. Yes, they are listening the class, they are responding. Then accordingly I will go with that. Shall I? Shall I go to the next one? Okay, done. Thank you. So I'll go. So refraction lenses, spherical lenses. There are two types of lenses: convex lens and concave lens. Convex lens and concave lens. So I'm taking the convex here. This is a convex, and this is a concave lens. Concave lens. Concave lens. Okay, this is a convex lens. Concave lens. Okay, so 5 minutes break, or we'll go to the 10 minutes or 5 minutes. So I'm going to the 10 minute because exactly at 10 o'clock 1 hour class over. So after 10 minutes break. Okay. So stay tuned. Student brand. Stay tuned to student brand. Will join after 10 minutes. Hi again, once again. We'll start again. 11, 10. So 1 minute. Now we'll go with the refraction. Refraction ray rules. Ray rules of convex mirror. So ray rules of convex mirror I'll discuss. Now we'll see ray rules of convex mirror. Is it visible to you all? Convex mirror. Sorry, convex lens, right? No one is saying, even I'm telling lens, convex lens. Convex lens. Here, see, I'm considering one lens here. So you can take two dots and draw those two dots. So optic center here, F1, F2, F1 to F1, F1 to F1, F2 to F2. Means this is one side and this is another side. Like that we are taking. That's why 1, 2. Okay. So now this is the one part. This is the one part of the sphere. Ray rules I am considering. One light I am taking like this. One light I am taking like that. Passes through focus. So first one. Okay, coming to the second one. So F1 to F1, F2 to F2. So one light I am taking like this. It passes like this. So here you can see the light ray is coming from infinity after refraction passes through F2. If light ray is passing through focus, after that it moves towards infinity, right? So now the last one. The last one I'm considering. Optic center F1 to F1, F2 to F2. Light ray passes through optic center. Here it passes like this only. So no refraction takes place. It will be undeviated line. Undeviated line. Clear? Any doubts? This is about ray rules of convex lens. Coming to the image formation. Image formations. So I'm considering optic center F1 to F1, F2 to F2. So object is placed at infinity. Object is placed at infinity. One light I am taking like this. Passes like this. Object is at infinity. Image will form at f2. Nature of the image is real inverted and highly diminished. Nature of the image is real inverted and highly diminished. Point 1. Next one, second one. Optic center f1 to f1, f2 to f2. So object is placed beyond to f1. Object is placed beyond to f1. One light I am taking like this. So it passes through focus like this. So another light I am taking like this. So that will meet here. So here I am considering here 2f2. So here is the object and here is the image. So object is here, image is here, object, image. Okay. So here object is placed beyond to f1, beyond to f1. Image will form between f2 and to f2, f2 and to f2. Nature of the image is real inverted. Nature of the image is real inverted. And coming to the size is diminished. Coming to the size is diminished. Compared to the object, image size is reduced. Compared to the object, image size is reduced. Is it clear? Anyone? Anyone have a doubt? No one. Okay, done. Next one. Object is placed at 2f1. Next one. Object is placed at 2f1. Object is placed at 2f1. Just check once. So we'll see. So how it is. So object is placed at so next case. So you can see I am taking the object. So this is the f1 to f1, f2 to f2. So f1 to f1, f2 to f2. Object is placed at 2f1 here. One light I am taking like this. It passes through focus. So another light, so it is optic center here. So object is placed at 2f1, here 2f2. Object is placed at 2f1. Image will form at 2f2. Nature, what is the nature of the image? Real inverted and same size. Real inverted and same size. Clear? So object is placed at 2f1, image will form at 2f2. Object is placed at 2f1, image will form at 2f2. Nature of the image is real inverted and size, coming to size, same size. Coming to the size is same size. So do you have any doubts? At least if you say respond, then I feel someone is there, so listening, then I'll go with the frequent mode. So that is about object is placed at f1. So next one, coming to the next position, optic center f1 2f1, f2, 2f2. So object is placed between 2f1 and f1. Object is placed between 2f1 and f1. One light I am taking like this. It passes through focus. So another light I am taking. So it will passes and meet beyond. So here. So here is a 2f2. Object between 2f1 and f1. Image will form. So beyond 2f2. Nature of the image. So what is the nature of the image? Nature of the image is real inverted. Real and inverted. And size of the image is enlarged. Enlarged. Clear? So object is placed at between 2f1 and f1. Image will form at beyond 2f2. So real inverted and size of the image is enlarged. Next one. Next image formation. Optic center. f1, 2f1, f2, 2f2. So object is placed at f1. One light I am taking like this. It passes through focus. Another light it passes through optic center. So these are the parallel lines. Parallel lines, we assume those light rays will meet at infinity. So f1. So image will form at object at f1. Image will form at infinity. Nature of the image is real inverted, highly enlarged. Size is coming to size, highly enlarged, because image will form at infinity. So at infinity image will form. Clear? Done. Next, last case, very special case, very important case. I'm considering like this. Optic center, f1, 2f1, f2, 2f2. So one light I am taking. So object is placed here. Object is placed. Object is placed. One light I am taking like this. It passes through focus. So another light it passes through optic center. Optic center. If you are extending, actually this here it is, place is not there. We'll adjust. So what we can do it, we'll adjust once again, because we have duster and marker, but in life there is nothing like that. Once you do mistakes, we can't erase it. We can't erase that part. So generally, if you see while you are editing, so we can edit and delete that portion if you don't like it. But in life, we can't edit. We can't delete. We can't select and delete. So I am not interested. I am not performing. I don't like this year. Will you able to select and delete in our life? No. Yes or no? Life goes as usual. We have to accept it. Clear? Come to the point. So I'm considering like this. So I'm taking here. So here optics F1 and optic center. So I'm taking one light ray here. One light ray, light ray, light ray, light ray, light ray. So I'm passing. Light ray is passing through focus. Another light ray passing through optic center. Optic center. Optic center. If you extend this light rays, those light rays will meet at one point. Those light rays will meet at one point. So if you want to draw like this, so light rays will meet here. Generally, if you place scale and everything, will get it. So I will tell how to draw this diagram. So if you want to get the proper, accurate, neat and extraordinary, mind-blowing, mind-blasting, mind-glowing, if you want that type of diagram, so I'll draw. Optic center F1 to F1, F2 to F2. So like this. So you have to place like here. So one lighter I am taking like this. So it passes through focus. So another lighter I am taking like this, passes through optic center. Optic center. If you are extending this light rays will meet at one point in the same side of the lens, same side of the object. So here I am taking like this. Clear? You got it? That's it. Time. That's it. That's enough. Simple, no? Very easy, right? Simple. Very simple. No doubt at all. Clear? Yes. So now we are going with the another one. It is placed between F1 and O. Object is placed between F1 and O. Image will form same side of the object. Image is formed at same side of the object. Image same side of the object. And nature, coming to the nature, this nature is very very important, so not nature, so not our nature, okay, that is very very important to live, to sustain, okay. So to take breath also, our nature is important, but here the nature of the image is virtual erect, virtual erect, virtual erect and enlarged, virtual erect and enlarged, okay. So do one like, I'll feel happy, okay. So when you say the answer, correct answer, what you will expect from teacher? So little appreciation. You don't need so much, everything like a BGM and background music and like that, some drums music not required. Simple appreciation, very good, nice. Here also, just if you do like and share and subscribe, oh, we feel very happy. So I'll get more energy, more stamina, more strength by your concentrating, showing interest. Then I can explain more. I can uh, teach more. I can give content more. Everything little more. Okay. So done. Come to the point. So object is placed between F1 and O. Image will form same side of the lens, same side of the object, same side of the object. Object and image will here image also same side only, so like that, okay. So That's enough. So concave lens, only two image formations. There also ray rules are same. And a power of lens, reciprocal of focal length is called power of lens. Formula 1 by f equal to 1 by v minus 1 by u. Magnification height of the image by height of the object. That's enough. So do you have any doubts? You can comment. You can comment section. Do comment. So those who want CBSE Grade 10 Physics course, okay. See, yeah, you can go through the playlist of in the student brand. In the student brand, if you go to playlist, there are no CBSE Grade 10 Physics. So based on, I prepared videos, light refraction, refraction videos. I prepared just to go through that. You will get it more content. So classes will be going like that. So this is for live class. I'm coming live to explain whatever content is available. So here you see, you can pay for 500 rupees to get CBSE Grade 10 Physics. So by Siva sir, BTech Mechanical, 10 years experience in physics teaching. So you can contact to this number to me, WhatsApp. So you have WhatsApp. WhatsApp is there on this number. You can say hi and you can ask doubts. Ask doubts. So ask me. So I'm considering. I'm going with one more new, um, what we can say, new method. Ask me. Physics. Ask me. Ask me through 98498128. So here, if you ask, I'll try to prepare the video and send to you. I'll try to the video and send to you. Ask me 9849812804. Through this, you can ask me any question related to physics. Okay. So related to physics, and if you have any doubts, 9849812804. If you have any doubts, you can ask. Okay. Physics. Clear? Anyone have? So you can ask 24/7. 24/7 option is available. You can ask 24/7. You can ask me. Answering it is different. I'll answer. So surely I'll respond to your questions. If you have any doubts, you can ask this any query or whatever I explained. So in this, if you have any doubts, 24/7. 24/7. Ask me, only ask me. Okay, you can ask 24/7. A reply, I will see. Okay, so according to the timings, according to the schedule, I'll reply. But I'll reply to each and every question. So if everyone are asking on the same doubt, means I'll prepare the video, or I will come to the live class. I'll come to the live class and explain also. Those who have any doubts. So I'm introducing this concept. Ask me through this number. Okay, WhatsApp is there. So to this number we have WhatsApp. You can ask. So if you want the course CBSE Grade 10 Physics, so 500 rupees. So with the cost of 500 rupees, I'm providing. So with the low cost, I'm providing the quality content. So and I'm providing the notes also. So 4 chapters notes and 100 definitions from 4 chapters. And 100 electricity problems. Also I'm giving. Okay. So with the cost of 500 rupees. So you can go with the ask me doubts. Ask me on this one. So I'll prepare a live class. Okay. Anybody is there? At least asking doubts also. For asking doubts, you no need to pay anything. So you can ask any doubt. So answering, I'll try to prepare a video. So if it is possible, otherwise, so in the live class, I'll try to answer those questions. Clear? So any doubts? Do you have any doubts? Shall we wind up the class? So thank you so much for your interest and dedication towards the subject learning. So this is our sir. So signing off. Namaste.